Okay, we'll take a look at problem number 43. And it's integration, performing numerical integration. And really, all it is we're trying to find the area under the curve. Okay, so we're going to write code very specifically for a specific function. So we need to write it for this function for 3x minus 2x squared. Okay, okay, looking at the actual function, the integrate function that is the one we need to modify potentially, and you'll see that um, uh, yes, we may need to we'll modify this, but it might be this is really what we need to modify, right? So first part here, let's talk about what this function actually does. Okay, what you do is when you're using this function, it takes three values. This is like your starting points. This would be this is trying to figure out like what are the size of the bases. So you'd set up like a first point and a second point. Um, really? Okay, so here's that program, um, chapter 6. This is example 12. And let's just take a look at this and see how this works. Oh, let me zoom in here. Okay. So basic idea, this particular program, here's the function. It's this is the function they're trying to get the area under for this program, 4e raised to the minus x power. Um, for us, we're going to have our own function, right? So there's going to be a different function, the function that's actually defined for this problem, which we'll use, okay? But the basic idea, you have two functions, or actually three because of the main, but you have two function prototypes. You have a thing called integrate, and which is calculating the area, and then a function, another function called the f, and this is the one that actually is like determining whatever value you pass in, it's evaluating that function. So for like x equal to 2, let's say it'd be e to the minus 2 times 4, right? So you pass in a value for what you're looking for the function at that point in time, okay? All right. So the way it works is this particular program, and we can we can use the code. We can actually go and just grab the code from this, code it up. Once we talk about it, we just go and get it, and basically this part is going to be all the same. And what this does is this is the number of trapezoids, right? Which is really just the number of little tiny areas that we care about. Okay. The next one is here's my A, and this is defining the intervals. Okay, so this is are the interval endpoints, I should say. So this one, you could even say that this is the oh well. So like here's my endpoint. So this is like my function starts at A and ends at B. Okay, so whatever. Like in our case, when we looked at the functions that I had written, the ones that where you have like either a rectangle or a triangular function. Um, A was like 0 and B was, I think I called it B, base, right? So for any function, you have these are your two endpoints, your start and end, okay? And then the area, of course, is the final result, the area underneath the whole curve, okay? So you just prompt the user for our values, A, B, and then the number of little trapezoids that you want to run. And so the expectation is that if you increase the number of trapezoids, you'll get a better estimate of the actual area, right? Okay. Um, in some cases, of course, some curves the area will be exact. Like if it was a straight line, it would be exact. Okay. So here's the end result is, so you run this function called integrate, which is on the next page, and you pass in the limits. So wherever the function starts, wherever the function ends, and the number of incremental areas that um, uh, you want to use. Okay. Then the next thing is you just go and print the results. Okay. So the code for all of this part, essentially everything on here is all the same. So you can just take it verbatim from the textbook. Okay, let's take a look at the integrate function. Okay. So here's the function, and here are the two endpoints. So this is like wherever my function starts in the along the x, and here's where my function ends along the x. And here's the actual number of little incremental areas or trapezoids that I want to calculate. Okay. So the first thing we do is, well, we declare the objects or variables that we're going to use. And then what we're going to do is we're going to come up with the base of each little incremental area. Okay. And then what we're going to do is we're going to loop around um, through some values. So we're essentially going through all of the values for our incremental areas. And we're going to use, like, here's my value of x. So each time I'm going through, I'm evaluating the function at x. So I have like a new value of x, a new value of x. As I increase x going through this loop, it's giving me a new value of the function at x. Okay? So we add all of the values of the function at x, add them all together. So these are the values, so essentially these are like the x's along this. So it's like x1, x2, x3, all the way down the line. Okay. That's what we're evaluating inside that loop. We're saying what's y1 at this point, what's y at this point, y3, y4, and we continue along in that fashion. Okay, continuing on with this. Okay, so we come up and we sum up all the essentially all the y values, right? And then what we're going to do is we're going to do, 1/2 times the base. And here's like our first value we're evaluating and our last value. That wasn't part of this loop. We just did them separately. But here are all the values of our function evaluated at all those points, right? Like x1, x2, x3, like we previously had all of the x's. So we did all of the x's together. So this is it's separate than, it's a little bit, sorry, not separate, but it's a little bit different than doing it, where you come up with each little incremental area. So what this does is it takes all of those values for our y values, essentially, sums all of those up together, okay? And then you multiply times 1/2 the base and you come up with the area, okay? So, and and the reason you see it's 2 here, 2 times the sum, if you look back at what we were calculating, if you notice, each time we came up with little incremental area, it was y2 plus y1, right? So it was these two values, right? And then essentially, they're very close together, so it's basically times 2, and we're coming up with um, that sum. This is like the 2 times the sum, right, that you see in the function. Okay, so the last part of this is that the function, right? This gets called every single time here. This is the function, and this is our function, the function that we were trying to find the area. Is 4 times exponent raised to the negative e raised to the negative x power, okay? And really, if you think about it, this is what we're going to modify in our code, okay? Okay, what I'm going to do is create a project here. And so this is our usual create a new project, console app, next. And I'm going to be chapter 6, problem 43. Okay, create. Okay, what I did is I went and just copied the program from the text. This was slightly different. This was for times exp minus x. Okay. So we can run this one and actually check to make sure it works. All right, let me get rid of that. Okay, let's see. Doesn't like something here. Oh, got like an extra one here. Okay. All right, so here is that program straight from the textbook. And we can actually run this one to check it. So this is, this is on page 325, 326, okay? So 4e to the minus x is what we're going to run. So we'll make sure that this works, and then we'll modify it. Okay. So the values that they use, I'll look in the text. They valued it from 0 to 1, and they used the number of trapezoids as 5. So that's what I'm going to run it as, okay? So a number of little incremental areas. I'm going to do it from 0 to 1. So 0, 1. Number of trapezoids, I'll do 5. And I should have done control F5, so I can't see it. Let me do one more thing here. Just do system pause. And like I said, I'm getting this directly from the text. And I'm running it with the values given just to verify that everything works, right? Before I change anything. I'm going to do 0, 1, number of trapezoids, 5. And I run it, and the area is 2.5369. And this is what they get in the textbook. Okay? So let me just close that. Okay, before I continue on to put the other function in, what I'm going to do is I'm going to modify this. I'm just going to do 3 times x. Okay? Let me just copy in my comment here. So I'm going to do y equals 3 times x. So we're going to go from x to 3, which means we have a 9 is our value for y. That's our height of our triangle. And, or the maximum height of the triangle. And then it's going to be times our base, which is 3, right? So our overall area for this triangle we're going to expect is going to be, 9 times 3, 27, and then half of it because it's a triangle. So our expectation for area is going to be equal to, let me put area here, is going to be equal to 13.5. Okay, so when we run it, I go from 0 to 3. Number of trapezoids, oh, whatever, 20, let's say. And there's my 13.5, okay? So this looks pretty good. You could actually go and, perform integration on the function that we care about and determine that if it's accurate. But I think after going through and doing these two functions, I think we're pretty good. So let's put in the function for this particular problem. And that is going to be 3 times x minus 2 times, and we'll use the power function. And that's going to be x comma 2. And there it is. Okay. And the only other thing we might need, CMath is already in it, so we're good with that. So then we can go and run it. And we can do it for whatever range we want. I'll do the same values. 0, 3, enter number of trapezoids. I don't know, 10, really doesn't matter. And here's our area, okay? So negative 4.59. And it comes up again. 0, 3. It runs it again after I have my virus checking running here. So let me see, 20. Okay, there's my minus 4.525. I mean, you could go through and, a typical thing you would do is you'd go through and verify the result with, you could perform integration on that function, although integration's kind of out of the scope of this class. But you could actually go by hand, do it by hand, and try a few values out and see if it works out if you want. But we could feel pretty confident that's good. We tested it for two different functions, and they both worked as expected. So that is it for this function. And like I said, pretty much all I did was, this was more like understanding how this works, right? Because I just took the code directly from the textbook, and then the only thing I needed to modify was essentially the function. And that's that.